Hi, in the previous video, we looked at how to use Flask to whip up a microservice that used HTTP to communicate with its users. In this video, we'll take a look at nameko, which will help us put together a microservice that communicates using the advanced message queuing protocol, which we can safely think of as a remote procedure call protocol, though that's actually only a part of what it does. Using HTTP to define the interface for our microservice has the advantages of familiarity and good integration with web technologies. But there's a certain amount of overhead involved in mapping the request and input data onto the functions and parameters that are actually meaningful to us. We could come up with abstractions that hide that part of the process, of course. That's essentially what the authors of nameko did. Although they used AMQP instead of HTTP to transport data and events. Installing nameko itself is easy. Use it pretty much the same pip command we always use. Be aware though that nameko won't actually work until we install some other software as well. More on that later. Looking at the nameko version of our person service, it's clear that the effort paid off. Our service is defined by a class with a name attribute and several member functions decorated with RPC. The member functions interface with the same database interface class we used in the previous video. In a very straightforward way, it would even be reasonable to combine the two into one class, and that's it. The complete definition of our microservice using nameko. Pretty sweet, right? It really is, but every cloud has a silver lining. And there are things we need to be aware of before we choose nameko or any similar tool. The first thing to be aware of is that nameko doesn't provide the complete AMQP infrastructure, it just connects to it. The AMQP infrastructure is responsible for conveying messages between connected programs in a way that is quick and reliable. That means we need an AMQP server running somewhere that nameko can find it. That means an AMQP server accessible to the microservice and an AMQP server accessible to the microservice's users. And those servers need to be connected to each other. They could be the same server, of course, but they don't have to be. Nameko recommends the RabbitMQ AMQP server, which can be downloaded from its own website. The installation is relatively uncomplicated, and there are detailed instructions on the site. Now that we have an AMQP server installed and running, can we connect to our service and manipulate person objects? Technically yes, but we need to use nameko to write the client too. AMQP isn't as simple to work with as HTTP, and the RPC mechanism adds an additional layer of complexity. We don't want to work with that raw. The first way we can interact with our microservice is manually using the nameko shell, which is an enhanced Python shell. First, we have to run the microservice, which we'll do in its own command window. Then we start the nameko shell and use the end.rpc object to access the functions of our microservice. It looks like we're just calling the functions, but actually we're communicating with the microservice through the AMQP protocol. The second way we can interact with our microservice is to create another microservice that depends on it. This test service periodically exercises the person service. It also demonstrates how to link one service to another, so that one of them is able to access the other. The key is the line that creates an RPC proxy instance on the class. When the service runs, it's able to access the functions of the specified remote service through that object. To run our test, we need to start both the person microservice and the test microservice, which we can do with a single command. You may have noticed that we return the object ID from the create function, rather than the created person object itself. That's because we can't return the person object. Nameko functions can return any data that can be represented as JSON. But that doesn't include instances of arbitrary classes. The same goes for parameters that are passed into a microservice's functions. They need to be within the limits of JSON. This isn't actually a more stringent restriction than we saw in the Flask microservice. It's just that with Flask, it was obvious we were sending data across the network in JSON format. So that limitation was obvious. With nameko, the requirement is the same, but the reason for it is easier to miss. In this video, we looked at using nameko's remote procedure call mechanism to implement a microservice, which simplifies the code significantly, at the cost of requiring that we set up an AMQP infrastructure, and more difficult interfacing with systems outside the AMQP network. In the earlier videos of this section, we looked at microservices are philosophically and what their advantages are, and implemented an HTTP-oriented microservice using Flask. In the next section, we'll look at how to interface between Python and compiled code to optimize performance bottlenecks in our code, and access libraries written in other programming languages.